Okay, I'm gonna do reviewing homework 44 and 45. I'm gonna do a couple problems from 44 and a few problems from 45. I already sent you out the answer keys to both of them, so you should be able to follow along if you want to. I'm just gonna actually talk you through a few of the problems, and that's gonna be what this video is all about. Homeworks 44 and 45. I'm just gonna do some example problems from them. So we're starting with homework 44. We're gonna do two problems from homework 44, number 31 and number 37. So we'll start with 31. Here's how it is. These are radical equations. So remember, square root this minus square root this. If they're stuck together with the minus, you cannot just square this and think that it's gonna make these square roots go away. Instead, what you would have, this is what you would do if you would try to square that right now. It would be this thing times itself. So it would be, and then you would have to FOIL this whole thing out. This thing times itself twice. You don't want to do that. What you want to do is get one of them on one side and get one of the roots over on the other side. Now, it doesn't really matter which one you move over, but look, this guy has a minus in front of it. How do I move it over to the other side? I do the opposite. So I would have to add this to this side to cancel the minus, or I'd have to minus this guy. Well, if I choose to minus this guy from both sides, it turns out that I'd end up with negatives in front of both of them, which is okay, but why do that if I don't have to have negatives? Why not just keep them positive? So for that reason, I would add this to both sides. That makes them both positive, great. It's not that big of a deal. They could both be negative, you'd still get the right answer and everything, but why not make them positive? So here we go. We're gonna have root 3x plus 1 equals root 2x plus 3. Now we can square both sides, and that eliminates the square roots by squaring both sides. But remember, anytime you square both sides of an equation, you are potentially introducing bogus roots. So we better check our answer at the end. Okay, so good news, that goes away, 3x plus 1. Good news, that root goes away, 2x plus 3. There we go. So minus 2x from both sides, right? I'm trying to move the x's over there, move the 1 over there. These cancel, these cancel. I get 3x minus 2x is x equals 2, which is my potential solution, right? How am I going to know if it works? Well, don't go back here. It's going to work here. Go back. Don't go even back here. Go back where the very first thing you started. Does it make this true? So let's put in 2. 3 times 2 is 6. Plus 1 is 7. This is square root 7, okay? Minus 2 times 2 is 4, plus 3 is 7. Square root 7 minus square root 7 equals 0. Yep, sounds right to me. So it is a good solution. Cha-ching. All right. Now, this is probably the ugliest one of the bunch. For sure, the ugliest problem on homework number 44. So here it is, number 37. Again, you do not want to do, here, let me show you what you do not want to do. Don't write this down because you do not want to do this. You do not want to do that guy squared. You do not want to square that guy. That would cause you to have to do this. Which would require FOIL and would not even eliminate your square root. You still would have a square root there. You would just have something much uglier. So you do not want to do that. You want to get the root by itself as much as possible, right? Which means if you look at the root, what's stuck onto it? An ugly plus 2. So how can I get rid of an ugly plus 2? What would undo plusing 2? Well, that would be called minusing 2, right? Because they're inverse operations. So now we get root 6 minus 3x equals x minus 2. Now I got the root by itself. Now I'm ready to square both sides of the equation. But guess what? All that stuff I was telling you I wasn't a big fan of, Okay, look, this is beautiful. Something nice happens here. Look, 6 minus 3x. But this is what I was telling you about. I would rather multiply this guy squared rather than this guy squared. This guy doesn't even have a root. So, but I am going to have to do this. X minus 2 times x minus 2. I am going to have to write it out twice and FOIL that. But at least I'm not dealing with ugly roots when I'm doing that. Okay, so let's FOIL that. Leave this the same. Oops, if I could write it the same, that would help. Okay, so we got, leave that the same, equals, if you FOIL this out, x times x is x squared minus 2x minus 2x. Minus 2 times minus 2 is plus 4. That's what you get when you FOIL it out. So in the next step, I can combine those into negative 4x, but I also want to make one of the sides 0 because I have a second degree or higher, x squared or x to the third or x to the fourth. You want to make the other side 0. Okay, so not like over here, I only had single power x, right? I didn't have x squared. So how did I go about solving that? I try to move the variable to one side, the constant to the other side. That's what you do when you just got a single power of x, x to the first power. Soon as you got a squared or higher, you want to make one of the sides 0, and you always want a positive number in front of the squared term. So that means I'm going to wipe out this side by minusing 6 from both sides and adding 3x to both sides. And then I get the great thing, this cancels, I get 0 is x squared. Minus 2x and minus 2x is minus 4x, plus 3x is minus 1x, minus 2. 4 and negative 6 is 2. And then I pray that this thing factors, because if it doesn't, actually, I don't know what to do yet. That's what we're going to learn next. What happens if this thing didn't factor? But guess what? Good luck is with me. I don't even have to know what would happen if this thing didn't factor, because it does. Two things that multiply to be 2 and subtract to be 1 would be 2 and 1. Different signs, bigger 1 minus. So the 2 is minus, the 1's plus. Then x is opposite this over this. Positive 2 over 1 and negative 1. So those are my two potential solutions, right? Let's find out if they're good or bad solutions. Let's see. Don't go back up to here. Don't go to here. Don't go to here. Go way back up here when you're checking it out. So let's start with 2. Let's try 2. 6 minus 3 times 2. That's 6 minus 6 is 0. Square root of 0 is 0, right? So 0 plus 2 equals 2. Yes, 0 plus 2 does equal 2. So this is a good solution. Okay, how about negative 1? 6 minus 3 times negative 1. Wait a minute, minus 3 times negative 1 is plus 3, right? So this would give me 6 plus 3, which would be 9. Square root of 9 is 3, so 3 plus 2 equals negative 1. 3 plus 2 equals negative 1. I don't think so. This is called a bogus solution, or as your book would like to call it, an extraneous solution. All right, so there you go. All right, so those are the two problems I'm going to work out from homework number 44. Now, homework number 45 was the same set of problems, just higher numbered ones, whatever. So it's from the same page. So I'm jumping into homework number 45 now. So number 51, here's how you do this one. First of all, good thing they're both on the opposite sides, but look, I got this 5 stuck onto here. Now, this 5 will divide nicely into 20, which is great. Now, what if this was a 3 instead of a 5? It would not go into 20. And then you'd end up, if I divided by 3 to get rid of it, I'd get 20 over 3, which would leave me with a fraction. If it's going to leave me with a fraction, I usually don't even divide it out. I would just leave the 3 out front there. But since it's a 5, it's not a 3. Since it's a 5, it will divide into 20 evenly. So the smartest thing to do here is get this root by itself by dividing both sides by 5. That cancels that. I get square root negative x equals 4. Now I'm ready. How can I get rid of the square root? I can raise to the second power. Raise this guy to the second power. Square root of negative x squared is negative x equals 4 squared is 16. But wait a minute. I don't really care what negative x is. I want to know what regular x is. So divide by negative 1 to get rid of the negative. X is negative 16, which is my solutionalis potentialis, right? So here we go. Let's see if it works. Watch, negative 16. Negative 16, that's called positive 16. Square root is 4 times 5 is 20. Yep, it sure checks out. It's a good solution. How about that? Okay. This guy, oh my gosh, this guy already has the roots on opposite sides of the equal sign. Remember the very first problem we did? We had to move it over so that they're on opposite sides, right? We didn't want them together on the same side. This one over here already has them on opposite sides. So actually, all I have to do now, believe it or not, square both sides, and I'm in good shape. Square both sides, and it becomes 3x minus 13 equals x plus 3. Oh my gosh. This is like the first month of last semester, whatever. Just very simple. Move the x's over here. Move the numbers over here. This cancels, this cancels. I get 3x minus 1x is 2x equals 16. Divide by 2 to get rid of times 2. And it gives me x is 8, which is my potential solution. Let's see, does 8 work? 3 times 8, 24. Take away 13 is 11. Square root of 11, okay? 8 plus 3 is also 11, so it's square root 11. Square root 11 equals square root 11? I think so. Sounds good to me. So there's the answer. Okay, a couple more problems. Okay. Okay. Let's see, I just did that one. Okay, now we're going to do page 727, number 59. Looks like this. This one isn't too bad. Square root x plus 6 equals 1. Wow. Well, this one is not bad. Check it out. The root is by itself, so just square and square this guy. I get x plus 6 equals 1. Oh my gosh, am I kidding me? Look how easy this is. What? X equals, whoa. It can't be that easy. But it is. Oh my gosh, can you believe it? Okay, let's plug it in. Negative 5 plus 6 is 1. Square root of 1 is 1 equals 1. Yes. Ha! Okay, whatever. Kind of anticlimactical there. But oh well, that's the way it goes. Number 61. Page 727, number 61. This will be a little more exciting. Oh, good. I like this one. X equals root 2x plus 15. Now that doesn't look too bad. It's not too bad. Hey, look, the root's by itself. That's always nice. Always nice when the root's by itself. I think that's good. So what am I going to do? Well, square it to get rid of it. But if I square that, got to square that. And oh my gosh, it's going to give me an x squared. So remember, when I'm solving an x squared, I solve that differently than if I just have a single x, like here or here, right? These x's, I tried to get the variables on one side, the numbers on the other side. When you have a squared or higher, you want to make one of the sides equal 0. And I want a positive number. The coefficient in front of here, I want to be a positive number. It's already positive. That means I'm going to wipe out this side. If this were negative x squared, then I would wipe out this side and move it over here so that I'd have a positive in front of there. That's the idea. So I do this. Sure enough, those both cancel. I get x squared minus 2x minus 15 equals 0. Then I go to factor. Remember how important I told you factoring was when we learned it? It's critical. You've got to know how to factor. X. Two numbers that multiply to be 15 and subtract to be 2 would be 5 and 3. Different signs, bigger one minus. So this one's minus, this one's plus. So x is 5 and negative 3, which are my two potential solutions. Let's see if they work. Again, you just check them one at a time. Let's check 5. 5 equals 2 times 5 is 10, plus 15 is 25, square root 25 is 5. 5 equals 5. Sounds good to me. How about negative 3? Negative 3 equals, 2 times negative 3 is negative 6, plus 15 is 9, square root 9 is 3. Negative 3 equals 3. If I have $3, is that the same as owing somebody $3? I don't think so. So this is not the same. This is a bogus solution, or as the book says, an extraneous solution. All righty, people. One more to go. One more. Oh, it's over here. Here it is. The grand finale, number 65. What is this? Number 65. Page 727, number 65. Says this. Root 2x plus 2 equals 2x. Okay, well, good news. Root is by itself. That's always good news, okay? Now I can square both sides. Now when I square it, I gotta square this whole thing here. So I'm gonna get 2x plus 2 equals 2 squared is 4, x squared is x squared. It's 4x squared. Then I go, look, it's squared, so I have to make one of the sides 0. This is positive in front of here, so I like it. So I'm going to wipe out this side by minusing 2x and minusing 2 on both sides. That'll make this side 0, just like I want, equals 4x squared minus 2x minus 2. Wait a minute. Oh my gosh. Good luck is with me, because I notice everything has a 2, baby! 2! So I can divide by 2 if I want to, but I don't have to. Okay, 0 is 2x squared minus x minus 1. Son of a gun! Now I try to factor this. Okay, there's only one way to break up 2x squared. It's got to be 2x and x. There's only one way to break up 1. 1 and 1. This is the only shot I got at factoring this. So let's see if it works. Let's see what the oi's are. 2x and 1x. Do they subtract to be 1x? Yes, they do. Bigger one's negative. So the 2x, which is the outside, needs to be negative. That means this is the minus, right? Making that negative 2x. We want the 1x to be positive. There you go. So the potential solutions are x is negative 1/2, opposite this over this, and positive 1. Cha-ching. Now, let's see which one it works, or either does one of them, or do both of them, or do none of them. Let's find out. Okay, negative 1/2. 2 times negative 1/2 is negative 1. Plus 2 is regular 1. Square root 1 is 1. So I get 1 equals 2 times negative 1/2 is negative 1. 1 equals negative 1. That is not true. 1 does not equal -1, so that's a bogus solution. Well, then that must mean that 1 works. Not necessarily. They could both be bogus. Or they could both work. It's not even guaranteed that one of them's not going to work if you get 2 answers. They could both work, or they could both not work. Okay, let's try 1. 2 times 1 is 2, plus 2 is 4. Square root of 4 is 2. And then you put the 1 there. 2 times 1 is 2. So 2 equals 2 is correct. So 1 does turn out to be a good solution. So there you go. Okay, so you have the entire answer keys for both of these things. So if I didn't work out your favorite problem or the one you had questions about, look on the answer keys. They're all worked out there, and they're worked out in great detail, and you should be able to look at them and figure them out. If you got any questions, you can email me.